Now we are going to assemble the electronics. Here is my Raspberry Pi 2B. I have a couple B pluses, but the 2B is much more spunkier when it comes to responding to opening windows and web and so on. So I'm just going to use this 2B on here. And the way they show it mounting is like this. Let's make sure that the holes line up, and it looks like they do. And we're going to get M2.5 *6 screws. As I've said before, Sunfounder is phenomenal in the way that they've packaged the hardware and made all this stuff available to us. If you try to do anything yourself on your own with Raspberry Pi, hardly know anything else, you'll notice how when it comes to the hardware and mounting and all of that, that stuff's hard to find. The little tiny screws that fit through these holes, they're hard to find. The standoffs, all that stuff. I noticed somebody who was making a comment on the Sunfounder site said that they thought the Pi should have a case, and I can understand why, because it might be pretty easy damaged sitting out in the open like this. But if you wanted to take this car further and add some different things, like, I don't know, some of your own custom sensors, for example, an accelerometer, or if you wanted to, one thing that this car doesn't have, and I wish it did, is wheel encoders, so that you can tell how fast the wheels are turning. And you can still add them. You can see the shafts back here on the motors. You could put wheel encoders on there, but you'd have to modify the chassis, and it looks like there might be some interference there. The wheel encoders would tell you if the wheels are turning, and it would allow you to measure the distance that your car has traveled. And so if you're measuring distance to objects and you want to drive around them, you're going to need wheel encoders. So if you wanted to add that, add other things, you'd probably use a Pi hat. And so because the Pi is open like this, that's still possible. With a case, you might run into trouble with that. Okay, so much for my lecture on the Pi. I believe this is the power converter. And it looks like that goes here. So let's do that. Notice how they have these shiny surfaces around the screw holes. They didn't do that on the Pi. It's more of a dull surface. Well, these shiny surfaces are metal. I am guessing that they are connected to some sort of plane that's connected to the heat producing parts on this board. And it gives them a little bit better additional way to get any heat off the board. When you're talking about power conversion, there's some loss of power in the conversion, and that turns into heat. That's why your cell phone charger gets hot, because you're putting in 120 volts AC and you're getting out, what, like 5 volts. takes energy to make that conversion, and that energy is dissipated in the form of heat through the electronic components. And sometimes the way you get the heat off is like this. Next bag. Speaking of heat, here's the motor driver. So this is a integrated circuit with a heat sink, and you can see this also has metal around the screw holes, so they probably are also going to try to get the heat out there too. I don't think you're going to generate a whole lot of heat. I mean, this is not going to get hot to the touch. I'd be surprised if it even got warm. These motor drivers are capable of some pretty high current, and these motors are, these motors, they're not wimpy, but they are pretty efficient. So we're going to put that guy here.